Well, at this point, you should be able to draw a 2D structure of a covalent molecules, right? So the Lewis structure allows you to be able to draw the 2D structure of molecules. By the end of this chapter, you should be able to draw the 3D structure of the molecule. The last thing you have to learn is right here, the molecular and electronic geometry. All right? Okay, start with something very simple here. Okay, so if I have two objects next to each other, okay, and then I run an electrical current through it. So one of them has a positive charge, the other one is negative charge, and they are nearby, next to each other. What's going to happen to them? Do they attract one another or they repel each other? Well, positive, negative, of course they attracts, right? All right, now go back to right here. So let's say if the charge of the two objects are the same, could be positive, positive, or could be negative, negative. What's going to happen? You can guess now, they will repel. All right? So positive, negative, they attract, negative, negative, they repel. Okay? So using this idea, there's a theory called valence shell electron pair repulsion theory. So basically, this theory is used to predict the molecular geometry of a molecule. What does it look like in real life in 3D structure? Okay. So and here how it works. So let's say if I want to construct a molecule that has one central atom and two non-central. All right. Now remember, each atom have some electron density. All right. They all have electron density. If you want to put these two non-central onto this central atom, what is the best structure that minimize electron repulsion between these two? Well, it's going to be linear. Put them as far away as possible. They have electron around it. This guy also have electron around it. Put them really close, they just repel, right? The best geometry of this, one central, two non-central is linear, right? They are farthest away they can be, which is 180 degrees from one another. All right? So we call this structure as linear. Now, let's say from linear, I want to add one more non-central. What's the structure is going to look like? Yeah, you can guess, right? So let's say I add another non-central onto this molecule. So I'm going to get something like that, right? But now, if you construct the structure right here, right? So these two non-central and this on the right side as well are too close, right? So the electron repulsion will push each other away to be as far away as possible. So this is going to push the other one down. Look like this. That's the best structure for three non-central atoms. We call trigonal planar. The bond angle is 120 degrees. All right. So from right here, I'm sure you get an idea now that atoms or the non-central atoms they repel one another. So when you construct a structure, when you construct a geometry, the geometry is gonna be the one that minimize the electron repulsion. Okay. All right. One more time. So I'm gonna twist this. So all three non-central are on the same plane. So that's why we call trigonal planar. So I'm gonna put it flat on the floor. Okay. So this one, they are on the same plane. This non-central is pointing towards you on a dash line, on a wedge line, and this guy on a dash line point away from you. Okay. So let's say if I want to add just one more non-central to this structure. What's the new structure? What would new structure look like? Will it look like that? Yeah, quite a lot of students would think, oh, it will look like that, but no, actually not. This here look like a square planar. They all are on the same plane. That four non-central are on the same plane. The angle between each non-central is about 90 degrees. But hey, they can do much better. I'll take a look right here. All right. So instead of putting this new non-central right here on the same plane, no, we put it on the top outer plane. Okay, so it looks something like this. When this new non-central approach this trigonal planar, the electron density, electron repulsion will push the rest away, push it down in this case. All right, so the structure that you're gonna get is tetrahedral. And the bond angle is not 90 degrees. This is much better. This is 109.5. All right. Okay? This is in 3D structure. If you put the new central on the same plane, you think of this molecule as a 2D structure, but is this actually in a real 3D structure, 3D plane? So you can put at the top right here, and that's got you a better bond angle because this molecule, the all non-central atoms are further apart than 90 degrees. Okay. All right, now let's get some more. So this right now we have 4 non-central. Adding one more, we're gonna add one more. All right. So if I add one more, this one gonna go from to the bottom, like that, and the electron repulsion. So from the bottom, gonna push the 3 of this guy up in this case, and we're gonna get trigonal bipyramidal. So trigonal means trigonal planar, the trigonal planar, and the bipyramidal. So they got 2 pyramid on it. So pyramid at the top, pyramid to the bottom. We call trigonal bipyramidal. All right. And last one, if I have another non-central, I'm going to add on to right here. So you're going to get it look like a square planar in the middle. Right. So we call it octahedral. If I rotate it, so look like that. Okay. Oh, we call it octahedral because it looks like there are 2 pyramids. Right. And each one of them have 4 faces. So there are 2 pyramids of 8 faces total. We call octahedral. Okay. All right. So the molecular geometry so far. So we have linear. This is for 2 non-central atoms. The bond angle is 180 degrees. We have trigonal planar. So this one is 120 degrees for 3 non-central atoms. For 4 non-central, the best structure is tetrahedral. And I force you memorize this number, 109.5. You have to memorize this number. Okay. This one you kind of like guess, right? 360 total, the angle total. 2 of them, 2 non-central going to be cut in half, so 180. 3 of them going to be 120, right? So 360 divided by 3. But for 4 non-central, they start doing 3D things now. So you get 109.5, right? Not 90 degrees apart. We have for 5 non-central, we have trigonal bipyramidal. And the bond angle between 1, 2, and 4. So this on the same plane, that's 120 degrees, just like trigonal planar. But 1 and 3 and 1 and 5, or 2 and 5, 4 and 5, 4 and 3, those are 90 degrees. Okay. Last one, octahedral. So for 6 non-central, the bond angle between 3 and 5 to 3 to 1, 3, 6, 3, 2, 3, 4, that's 90 degrees. All of them are 90 degrees apart. All right. Okay, all right. Now, you have to be able to predict the molecular geometry, okay? So first off, this is what you should do. Draw a Lewis structure, a 3D structure first, and then consider what is the best geometry for each molecule, okay? Check this with me on the next video.